Hello, welcome back. In this video, we are going to learn about UDP Overview Part 1. So let's look at the agenda. We are going to learn about UDP Principle of Operation, then Connectionless Services, after that Flow and Error Control of UDP, then Checksum. What is the UDP Principle of Operation? UDP uses ideas that are common to the transport layer. For example, process to process, delivery. If you recall, we have the application layer, then the transport layer, then the network layer, after the data link layer. After that, it is a physical layer. So UDP works at the transport layer. We can have several processes running at the application layer. They move to the TCP layer via the socket interface, and it is the UDP protocol that is used at the transport layer for process-to-process delivery. Process means a program in execution. It is mainly used for connectionless services. For UDP to operate, there is no need of any connection setup. Data are sent as small datagrams. There is no sequencing. So this is a very simple connectionless service and having no reliability. So UDP is used for small size data. Next, the flow and the error control of UDP is very simple. UDP has no flow control at all, so there is no sliding window in UDP. And regarding the error control, it uses a very simple checksum. We have already learned about the mathematical representation of checksum in an earlier video of error detection and correction. So checksum of UDP is slightly different from that used in ICMP and IP. We will learn about how checksum is implemented in UDP. Then encapsulation and decapsulation are also the major functionalities of UDP. After that, queuing is a very important functionality of UDP using different port numbers. Connectionless service. As we have earlier said that UDP is connectionless, meaning that no path setup is needed. Let us consider a client-server application where a client makes a request to the server and the server gives the response. So this is a simple client-server application where UDP may be used. Since this is connectionless, there is no need of path setup and no need of path termination. The data must be small size and each packet is treated as an individual datagram. Now, since this is connectionless, there is no reliability also. But the only advantage is that it is very simple. Regarding the flow and the error control, as we have already said, that there is no flow control. The receiver may be overwhelmed by different packets, and so no flow control mechanism is possible either from the sender end or the receiver end. It is then the responsibility of the process that is using the UDP to implement this flow control mechanism in its own process. Now, UDP has a very simple error control mechanism. It uses checksum. Now, I will tell you how checksum operates at UDP. Checksum has a pseudo header, a UDP header, and data coming from the application layer. So this is the pseudo header. It consists of the 32-bit source IP address and 32-bit destination IP address. Now there is a field with all zeros. Then a protocol of 8-bit is there to indicate that it is UDP. Then the UDP total length is given here, which is of 16 bits. After that, we have the UDP header, which consists of the source port address, which is of 16 bits, and destination port address, which is of 16 bits. Now then we have data coming from the upper layer, that is the application layer. Here it gives the UDP total length, which is of again 16 bits, and the checksum, which is of again 16 bits. Now, data padding is necessary to make data multiple of 16 bits. If we have data which is not a multiple of 16 bits, then we need some data padding. Let's understand checksum with the help of this example. As given here, this is the source address, this is the destination address, and all other fields as given in the previous slide. This is basically the data part coming from application layer and all other necessary fields. So how do you write? We basically divide the address into 16 bits. So for the source address, the first 16 bits will go here. So 153.18 will go here. Then the next 2 bytes, 8 and 105 go here. Now we will understand about the destination address. The first 2 bytes, 171.2 will go here. The next 2 bytes, 14.10 will go here. After that, it is all zeros, so 0. So this is basically the padding. Then it is 17. So 0 and 17. Then after that comes 15. Then 1087 followed by 13. Then it is again 15. After that 0. Then the data T and E. After that data S and T. Then data I and N. After that data G and 0, which is again the padding. Then this is the sum field and this is the checksum field. So in this way, the checksum is implemented in UDP. Please note here that if you do not want to use checksum, then here we have to keep all bits as 1. It is not logical that in spite of using checksum, you get checksum as 1, 1, 1, all ones. Because in that case, the sum must be all zeros, which is really impossible, because for sum to be 0, all the data fields should be 0, which is not possible. To summarize, in this video, we have learnt about the principle of operation of UDP, different connectionless services that are provided by UDP. We have understood the flow control and error control mechanisms of UDP. We have understood that error control mechanism is checksum and UDP does not have any flow control mechanism. Thank you.